Kim holds a 2 kilogram air rifle loosely and fires a bullet of mass 1 gram. The muzzle velocity of the bullet is 150 meters per second. What will be the recoil speed of the rifle? This is an example of a collision in reverse. It's a good one to start off with because it demonstrates how there will be conservation of momentum, and you can actually solve the problem from that alone. You don't have to use energy concerns. The formula we're going to need here for conservation of momentum is that the sum of the initial momentum equals the sum of the final momentum. Now there's going to be two objects involved. There's a gun with a bullet in it initially at rest. Later, the bullet is going to fly out at high speed, 150 meters per second. The gun is going to recoil, meaning it's going to have a speed that is in the opposite direction. And that's what we're trying to find, is what is that final speed. So we want to assign a letter to the gun and the bullet, A and B. A is the gun, B is the bullet. Okay, so now we need to fill in the equation. Just by looking at the situation, we can see that at the start, our system had 0 momentum. And so that's what we want to put in here, a 0 for the initial momentum. But when it comes to the final momentum, we need to substitute in the formula for momentum. MAVA is the mass of the gun times the velocity of the gun. MBVB is the mass of the bullet times the velocity of the bullet. We would now try to plug in everything that we can. It's a 2 kilogram gun. We don't know its final speed. The bullet is 0.001 kilograms. And its speed is 150. Now we would just want to solve that equation for the final recoil speed of the gun. It's 0.075 in the negative direction. Now, rather than being an example of a perfectly inelastic collision here, it's the reverse of a collision. It's more like an explosion. But the same principles apply.